Hi, my name is Raphael and I'm taking the course CS50's Introduction to Game Development, and this video is about assignment 2, Breakout, the Powerup update. So I will present you my solution for this assignment in this video. So let's take a look at the goals for this assignment. So in short, we need to add a power-up, which spawns if a brick is destroyed or hit often as you like. And if you collect it with the paddle, it should spawn 2 more balls, which of course should behave like the original ball. If you lose a health, then we need to implement a paddle resize. So we should be able to grow the paddle or shrink the paddle. As we've seen in the lecture, we have more paddle sizes than we have tried out in the solution in the lecture. And if we lose a heart, it should shrink, and if we get a high score or get a certain amount of score, it should grow or get bigger again. And the third thing is we need to add a locked brick, which is also in the image file. So we need to generate a quad for it. And there's also a key power up, which we need to integrate for this. And the key power up behaves like the other power up. So if you collect it, you should be able to destroy the key brick or the locked brick. And if you don't have the key, you should not be able to destroy the locked brick. So let's jump into the code. Let's start with the power up. So let's look at the picture here. I have chosen the 9th power up because I just liked it. So, but I wrote a function to which extracts all of the 10 power-ups, of course, and this is located in util.lua. So I call it generate quads power-ups, and it starts at x0, y192 because it's pretty low down, and basically just 10 times love.graphics new quad with 16 by 16 size, and then go 16 pixels in the x direction, of course, and return all quads. And these are assigned in the main.lua at line 69. So here we have G-frames, and there is another entry which I added with the key power-ups, and with this, which calls this function basically. With the main texture. Okay, then of course we need a power-up class. So it's here. With an init function which just sets basic variables, position, and so on. I set dy to 20 and dx to 0 because we want the power-up to drop slowly, and takes a skin so we can decide which power-up we want to render, and it has a in-play variable which comes handy later. Then it has a collides function, which is the same as the ball collides functions, so just AABB collision detection. And with an update function where we just update the x and y, and we have a render function where we just render with the generated quad power-ups from the main texture and the key skin. So in my case this is 9. Okay, let's go to the play state, to line 31. Yeah, so this is also a change I made because now we have to take into account that there can be more than one ball on the screen, or also like as data structure. Therefore, I just changed the self.ball variable to self.balls, which is a table, and it takes at placeStateEnter function takes one ball, so which is passed from the surf state. And then we give the starting velocity to the first ball in balls. Then we also need a table for power-ups, because you could also have multiple power-ups at once on the screen if you are very lucky. So this is just probability based, but it could be, so better to keep it in a table, and it's also easier to handle. Good. Let's continue. So here, for example, we just go through the power-up table and update every power-up, and as we can see here, of course, before we just called self.ball update, we need all operations which we perform now on a ball or balls, we need to put now in a for loop, because we have now a table of balls and we have to consider that we have multiple balls. So as we see here also, but I won't go to this now. So let's continue on line 106. So yes, here we are at if brick in play and ball collides brick. So we hit a brick, then we call the brick hit function. This is for the key power up. And then at this if statement, if not brick in play, so we destroyed the brick, we want to spawn a power up. Not every time, but we want to spawn one. So I defined a variable, and then if self.getPowerup, which gets past the brick. So this is a function I wrote, which is just a probability function, so to say. It just takes into account the init tier and the init color, which I also added to the brick class. These are basically just two variables which hold the initialized tier and color, because the tier and color variables change during game time if you hit a brick, and these do not. So basically, if a brick is a high tier and a high color, so to say, it's a higher chance you get a power up. Good. Okay, back where we left off. So if this is true, then create a new power up object with skin 9. So this is the power up I chose for this. And then if we instantiate an object, this is because we also could instantiate a key power up. I will go to this later. We just set its x and y's to the brick center at the bottom. So if you destroy a brick, the power up spawns at the brick's location, and we insert, of course, the power up object in the power up table, so we can refer to it later. Good. Now we move on to line 213. Yeah, power up collision. So of course we also want to collect the power up, and we just call the power up collides function and pass in the paddle. And if this is true, so for each power up, of course, we play the confirm sound, because I was too lazy to get a new sound and I thought it sounds pretty nice. And then we hop into this else here, because it's not a key power up in this case. And for for I 0 to 1, so 2 times, we create a new ball object, assign it a random skin, and the position is the center of the paddle, like in the surf state where you start to surf the ball, random velocity, and insert the ball into the ball's table and change the power-up in play to false because we collected it. And then, of course, we remove all power-ups which we have collected or which we have missed if they're like their y is greater than virtual height. Good. And also, this is also new. We remove the ball, a ball of the balls table if it's y is greater than virtual height, because we have now multiple balls. And if the if the balls table has no entries anymore, then we have lost, or we have lost a life or lost a heart. And yeah, so this logic changed a bit because we have the table now. Good. Line 300 with something. Okay, yeah, this is just in the render function. We of course render the power up. Okay. I will continue on with the paddle resize update, or grow and shrink update. For this we will go into the paddle class at line 79. Yeah, so I've just wrote two functions in the paddle class itself. So paddle shrink, paddle grow, and it just changes the size and width, of course. And if the size is greater than 1, because we don't want it to get lower than 1 or less than 1, we just decrement the size. We decrement the width with 32 pixels, because that's the difference between the paddle sizes. And then we also change the x coordinate plus 16, because this is the 32 divided by 2, and we want to extend it, shrink it like that the center stays in the center, so it does not shrink only on the right side or on the left side. Would be on the right side, I guess. And grow is basically the same, just incrementing. So if size is smaller than 4, because 4 is the maximum size, plus 1, width is also incremented, and we change the x coordinate so that it changes from the center. Okay, and with a thing which is very convenient, that the render function already is ready to handle different sizes, as we see here, self.size plus 4. So if we change the size, also another paddle is rendered. So this was already done for us. Good. Let's look into the play state for the changes. Line 43. Yeah, so if I just added my grow function here, so we have if statement here. If score is greater than recovery points, we get a health, and we also I also wanted to grow the paddle here. And yeah, then we have to find the position where it shrinks. It's at line 258. Yes, so if all balls dropped out of the screen, basically, we will shrink the paddle if we have not lost completely, and then change to self state again. So this was everything for the paddle resize update. And then we have the update with the locked brick. So quickly in the image file, it's this brick, and we also have a key power up right here. Okay, for this I added in the main.ly function a render key power up function, which just renders the key power up like on the top of the screen next to the score. I believe we will see it later, hopefully, and just draws the power up with skin 10. So yes, and then let's look into the brick function. class, sorry, at line 97. So yeah, I modified the brick hit function a bit. So as you see, we have a key parameter here. So we pass in basically true or false. And if the brick is locked and we have no key, we can just return because we can't unlock it anyway. But if it is locked and we have a key, we can set self in play to false because then we destroyed the brick, and then the other logic is applied, and which is not applied because it's an else if and else. And then if the brick is not in play, this another brick hit sound is played, of course. Good. And also the particle system emit particles if we hit it. Good. Brick 117, 154. Yes, so I added a variable called locked position, and this gets 2 if we have a locked brick, because out of all bricks in this quartz table, it's the last entry, and if we set tier and color to maximum, we need to add 2 more to get to the brick position, because we have 22 bricks and this is maximum 20, and the 21st brick is black brick, we don't need it, we want this one. Good, so let's look into the level maker, where I need to show you some changes I made. So first, local level map is just a wrapper table for bricks. We will see it later on why this is good. Then we have 2 new variables here, locked column position, locked row position, which are initialized with 0 because maybe we don't want it. And I just decide here randomly if we have a locked brick in this level. So it's a 33% chance, I believe, because we see if it's 1, and it can be between 1 and 3 through math.random. And if this is true, then we make a decision about the position, which is also random between 1 and the number of columns, or 1 and the number of rows. Then we go to line 90, where if we skip a block, and this block happens to be the block where we would have drawn the locked brick, we just increment the column position of the locked brick so we don't miss it out. On line 128, so basically here, if locked column position and row position is x and y, so we iterate with x and y somewhere, yes, to generate rows and columns. And if this is the desired position, we set the color to 5, which is maximum, the tier to 3, which is maximum, locked pos to do, as I showed you before, and is locked to through. And we also set init color and init tier, but which is not bound to the locked brick anyway. Good. And at the end, we pass into the level map wrapper table the bricks, where we previously only returned the bricks, and we add a second key into this table, which is locked, and it gets the value locked, so true or false, so we can distinguish on later in the game if this level has a locked brick or not. Then we return this whole table. Good. Let's go to utility really quick, because I changed the generate quartz bricks, and before I applied my changes, we just returned this table slice from generic quads. And now I also added another quad to this, which is just 24, 24 at position 1, because this would return a table and we want a quad. And there's only one quad in this table. And 24 is basically just the position here. So we have here 6, then with 12, then with 18, then with 24. Good, so the iteration basically. And then we return the bricks table, of course. Well, not much more to say, but we need to go into place state once more time at line 99, where, yeah, as I explained before, we hit a brick, and now we also pass in self.key, which is a variable if we, which determines if we have a key or not, which is just a boolean. And at line 103, yeah, also made changes to the score, so we just add 500 to the score if it was a locked brick, and also color and tier are maximum values, so this is also high, so this score is pretty high here, which is also good because it's a special brick. Good, 112, where this is where a brick is destroyed and we determine the spawner Powerup, and I also created a function right here, which is, so if the brick is locked, of course, we call self.getKey, which is also just a random function, and it returns us if math.random between 1 and the remaining bricks which are in play, which are determined by this little function, so I just count them, is smaller than 2. So the less bricks are in play, the more is the chance that you get the key power up, and if you don't get it and you're very unlucky, you definitely get it at the last brick before the key brick. So this is in short. Good. Line 112, where we left off, yes. So if this is true and we don't have already a key, and there is no key which is currently dropping, so this function just looks if in our Powerup table is already a key Powerup. We create a new Powerup object with skin 10, which is the key skin, which is down here. And yes, and we insert it in the table, of course, and assign it an X and Y position. Good. Here, if the brick is locked, so we basically just are in a statement where we destroyed the brick. So if the brick is locked, then we set our key to false, because then we have already unlocked it, and set self.locked to false. Yeah, so this means that in this level is no more locked brick anymore. Good. Line 217. This is, yeah, the Powerup collision, as same as I explained before. So for the other Powerup we spawn the ball, and here we just set self.key to true. And at line 308, if self.key is true, we render the key Powerup. So we will see the Powerup on the screen if we have collected it. So that was basically it. Additionally, I have also added some more parameters which are passed between states, but this is pretty easy, so I don't want to explain to it. So we have the locked variable, which stands for if a locked brick is contained in the level, and the self.key, which indicates if we have a key or not. Good, I would say we start the game and maybe we can see some features. Good, okay. I will just restart it over and over till we have a level with a key break. So here we have one, and I will play a little bit. Probably I will fast forward for you. Oh, nice. We have 2 power-ups already. Key power-up and... ooh, this was close. More balls and a key. And as we see it... oh, pause. So, as we see right here at the top, the key power-up is rendered because I collected it. And we also see that the balls have spawned. So now we should also be able to destroy the key brick if I don't mess up. So now we have 2 balls, which of course behave as one, so I decided to keep this one. How close? I wanted to destroy the key brick. Let's see if I can make it. Good, we have another power up here. Ooh, this is actually so much fun. Oh, now we destroyed the key power up, very nice. So that's basically all to see. Maybe I can lose really quick to see the shrink. No, not really. So now my pal should shrink. Yeah, as you see, we have a small pal now. And also, if we should reach 5,000 points, it should grow again. And then I think this is enough to show off. Oh my god, I think we can make it in this level. Okay, let's see. Okay, next hit should be a grow on our pal, hopefully. No. Next one, please. Oh yeah, 5,000. Oh, it's not growing. Maybe one more. Oh yeah, and now we have a bigger pal again, and this can also get much more bigger, but I think this is enough. Yeah. Oh, game is not closing, so thank you very much for watching. I hope you did understand what I have done to this code, so what my solution was. And yeah, see you in the next video. Bye.